you should try and get yourself a graph plotter and start playing around with it. So, for example, if you know y equals x to the power 3 will look something like this here. Well, and then x to the power of 2 will look like this. We'll start combining graphs. That's what I've been doing with all the questions I've been giving you. So I know this graph looks like this. I know this graph looks like this. So I would start playing around with like asking you try and sketch y equals x to the power 3 plus x to the power 2. So basically I'm asking you, well, get yourself a graph plotter and ask yourself what happens when you start combining this graph with this graph here. So have y equals x to the power of 3 plus x to the power of 2. So start combining the two graphs. Or you know y equals x will be a straight line going through the origin, and the reciprocal graph will look something like this. Well, start combining. Let's say what would happen if you combine this graph with this graph. So suppose you have y equals 1 over x plus x. What would this graph, what will it look like? So basically, if you want to investigate this, then ask yourself, which term or which part would dominate when x is small, and which part would dominate when x is big? So looking at these two, well, just play around with it, and then you've got this graph here where if you have a value of a here, like for example y equals 2 to the power of x, it will look something like this. Now if a is above 1, then it's going to be like this. Okay, so for example, this graph y equals 2 to the power of x will look like this. Okay, it's an exponential growth because it's growing. Whereas if you have this graph here, y equals, well, when a is less than 1, let's say y equals 0.7 to the power of x, then it's exponential decay because it's getting smaller and smaller. Well, what would happen if you start combining, let's say this one here, y equals 2 to the power of x, say, or 3, it doesn't matter, plus, let's say, what would happen if you combine it with this, 1 over x. So what will this graph look like? So play around with it and ask which term dominates when x is small, and which term dominates when x is big. So for example, for your next one, we're going to investigate this one. We are going to combine this one with this one here. So what would happen when we try and plot this? Y equals 2 to the power of x plus x. Okay, so this is the next example here. So see if you can press pause and have a go. Press pause and have a go. See if you can guess what this graph will look like. Okay, so this graph here, well draw roughly, draw your rough graph here. Okay, now let's investigate when x is small, which term dominates. Okay, let's try and investigate when x equals 0. Okay, if you put 0 into here, this term here will be 1, because 2 to the power of 0 is 1, and then you plus 0. So this whole thing here will be what was it? It will be 1. Okay, so when x equals 0, this term dominates slightly because you had 0 and then you had 1 over here. So this term dominates. Now let's put 5 into here. 5 into here. So this term will be 5. This term will be 2 times 2 times 2 times 2 times 2. So this bit here will be 4 times 4, which is 16. 16 times 2 will be 32. So this, you see, just this term alone, it would be 32 versus 5. Because when you put 5 into this thing here, it would be 5 here, and this is 32. So already this term is starting to dominate already. Because 32, when you add it to 5, okay, 5 plays its part, but not that much in comparison to 32. Well, overall, it would be 37. But you see, this term you can already see is starting to dominate. Now put 10 into this thing here. So 10 into the x. So this over on this side it will be 10. Okay, now put 10 into here. It will be 2 times 2 times 2 times 2 times 2 times, that's times 2 times, well, already this is going to be a big number. In comparison to this, this term, well, if you really want to know, do 2 to the power of 10. I think it's going to be a big number. And then already, well, this is going to, well, you can tell that this is going to dominate this when x equals 10. So already we know that when x is greater than 0, we know this is this term here will dominate. So you can expect the graph to look something like this: 1 here, and then it will follow this this trait here. Okay. So it will follow y equals x to the 2 to the power of x. Now let's look what happens when x is, let's say minus well, we can investigate when it's minus 1. Let's see what will happen. So this one here will be minus 1, okay, and then if you put minus 1 into here, it will be 2 to the power of minus 1. But we don't really understand what's going on when it's to the power of minus 1. So immediately jump to 1 over 2 to the power of 1, which is a half. So well, you got to understand your indices here. So maybe you have to look back in one of the earlier chapters. I've done lots of videos on indices. So well, anyway, when you put minus 1 into here, on this side here you will have a half, and then on this side here you will have negative 1. So okay, already we are starting to see that this term is starting to dominate. Because minus 1 versus a half is not that much of a difference, but still this term dominates. So this would be a half. Well here it doesn't make that much of a difference. Let's investigate. Let's investigate minus 5. So now minus 5, put it into here. So this term here will be minus 5. If you put it into here, minus 5, it will be 2 to the power of minus 5. We don't really understand it when it's to the power of a minus 5. So immediately jump to this, 2 to the power of 5. You see, this number here is going to be big, meaning 1 divided by a really big number, the whole thing here will be really small. Because if you look at the graph of 2 to the power of x, it will look like this. Now as you head towards here, it's not going to be much of a difference, whereas y to the power of x is going to be a big difference. Well, anyway, when x is negative 5, this one here will be negative 5, this one here will be a small number. So here negative 5 dominates. Now if you have, say, negative 10 here, negative 10, so you can see that here it will be negative 10, here it's going to be very small, okay, because you've got 2 to the power of minus 10, that's going to be a small number, because it's really 1 over 2 to the power of 10, which means this whole thing here will be small. Now if you go to minus 1000, this number here will be minus 1000, and this number here is going to be 0.0000, I don't know what. It's going to be a really small number. So again, this here dominates. So looking at this table here, you can guess what the graph will look like. When it's 0, it's going to be 1 here. Okay, and then as you increase in this direction here, this term dominates. So it wants to follow this. It wants to do that. This is 2 to the power of x. But not exactly 2 to the power of x, because you still got to add this insignificant amount onto it. Okay, but it will still look something like 2 to the power of x. Now when it's and then it starts to decay down here like this. It starts to go downwards, and then as you increase x in a negative direction, it wants to follow this. It wants to follow the y equals x graph. Remember, y equals x looks like it goes through the origin like this. But over in this domain here, we can forget about this because it gets overtaken by 2 to the power of x. But then on this side here, it starts to dominate. So maybe around here, it starts to merge it with this. I don't know how, but it's going to start to merge it like this. So overall, your graph will look something like this. Hang on. It will look something like this. And then somehow it has to join up with this, going through the origin here. Okay, but I'm going to guess it to be something like this. Okay. Well, anyway, let's see what it really looks like. See, oh, okay. So here, this bit here is 1. So it wants to follow the y to the power of 2 to the power of x here. But then over in this direction, it's starting to adopt the y equals x. And this here, it wants to go through the origin here. But then here, it's merging between the two. So this bit here, you really have to guess. You have to guess how the two will join up. But around here and around here, it should be educated guesswork. Okay, so your graph will look like this. Again, start by, well, get yourself a graphing calculator and start combining things like this, and maybe weight it as well. When I say weight it, if you want to combine this and this, maybe you could have y equals x to the x squared plus x, and then maybe weight it. Put a 9 in front of this. Give this bit a bit more weight. So it will adopt this personality a bit more. Okay, or well, anyway, start playing around with it, combining different graphs and see what it looks like. Okay.